All right, and welcome back. In this video, we are going to be going through Chapter 7, Section 3, titled Similar Polygons. And by the end of this video, we should be able to state and apply the properties of similar polygons. So please have out your guide and notes. Let's begin. So similar polygons have the same shape, but not necessarily the same size. The two polygons are similar if their vertices can be paired so that corresponding angles are congruent and corresponding sides are in proportion. So if polygon ABCDE is similar to polygon FGHIJ, notice the similar symbol, a little squiggle. Then angle A is congruent to angle F, angle B is congruent to angle G, angle C is congruent to angle H, angle D is congruent to angle I, angle E is congruent to angle J, and the following proportions can be made. AB over FG is equal to BC over GH, which is equal to CD over HI, which is equal to DE over IJ, which is equal to AE over FJ. Notice how all of the sides in the numerator correspond to polygon ABCDE, and all the sides in the denominator correspond to polygon GFJIH. Sorry. So whenever we have our proportions, we have to make sure that our labels are similar. So if we had AB over FG, we'd have to have BC over GH since AB is part of polygon ABCDE. Likewise, BC would have to be part of polygon ABCDE. So with this in mind, please work on problems 1 through 3 on the guided notes and resume when you're ready to move forward. In example number 1, we are given that quadrilateral ABCD is similar to quadrilateral WXYZ. We want to find the measure of angle B, find the measure of angle Y, and the measure of angle D, as well as the measure of angle Z. So let's go on through. Well, measure of angle B is equal to the measure of angle X, and we know the measure of angle X, is 60 degrees. So the measure of angle B is going to be 60. Well, we also know the measure of angle Y is equal to the measure of angle C, since they are corresponding, and we know the measure of angle C is 130, therefore the measure of angle Y also equal to 130. We know the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D is equal to 360 because the sum of all the angles of a quadrilateral is 360. So as we substitute in our values, we can find the measure of angle D is 80 degrees, which is also going to be equal to the measure of angle Z. Awesome. With this in mind, please work on problems 4 through 6 on the guide. Resume when you're ready to move forward. So if two polygons are similar, then corresponding sides are in proportion. The ratio of the lengths of any two corresponding sides is called the scale factor of the similarity. One convenient way of labeling vertices of similar polygons is shown in example number 2. A prime is read A prime, which is why I read it that way. Woo! Example number 2 gives us the quadrilateral ABCD is similar to quadrilateral A prime, B prime, C prime, and D prime. We have to find the scale factor and the values of X, Y, and Z. So let's look at what we have here. AB corresponds to A prime, B prime. AD corresponds to A prime, B prime. BC corresponds to B prime, C prime. And CD corresponds to C prime, D prime. So knowing this, we can find a relationship between our values. Well, we know that AB is corresponding to A prime, B prime. So we can use that to find the scale factor. And the scale factor is going to be 6 over 5. Because if we go from the bigger shape, ABCD, to the smaller shape, A prime, B prime, C prime, D prime, well, then AB over A prime B prime is 24 over 20, which is 6 over 5. So the scale factor is going to be 6 over 5. Or ABCD is 6/5 bigger than A prime, B prime, C prime, D prime. As we go through, we can create our general proportion, which would help us solve for X, Y, and Z. So we can substitute in our values and we can go from there. Well, we can break it up. 6 over 5 is equal to 30 over x. 6 over 5 is equal to y over 15. And 6 over 5 is equal to 27 over z. It's very helpful to use a scale factor when finding these values of our variables. And as we solve, we're going to get that x is equal to 25, y is equal to 18, and z is equal to 45 over 2. With this in mind, please work on problems 7 through 9 on the guided notes and resume when you're ready for one more example. In example number 3, we are given quadrilateral GEOM, similar quadrilateral G prime, E prime, O prime, M prime. We have to find the scale factor, the perimeter of GEOM, and the perimeter of G prime, E prime, O prime, and M prime. Well, let's look at our figures. MO corresponds to M prime, O prime. Let's see, GM corresponds to G prime, M prime. Notice how we have some values here, 18 and 24. And MG over M prime, G prime would be 18 over 24, and we can use that to help us find the scale factor. So GM over G prime, M prime is 18 over 24, which is 3 over 4. Going from the first quadrilateral, GEOM, to the quadrilateral, well, the first quadrilateral is 3/4 the size of the second quadrilateral. The scale factor is going to be 3 over 4. We can plug in everything we know for GEOM and find the perimeter, and we get that it is 90. Well, we can find the perimeter by first finding the missing lengths. Or you can use a property of proportion. So we have our general perimeter here. We have GM over G prime M prime is equal to GE plus EO plus OM plus GM all over the sum of the other 4 segments in the other quadrilateral, G prime, E prime, O prime, and M prime. And as we solve, we get 3 over 4 is equal to 90 over x, and x is equal to 120, which means that the perimeter is 120. So there are multiple ways to go about it, but we could have used a property of proportions to make it a little bit easier for us. With this in mind, please work on problems 10 through 12 on the guided notes. Great job. You did a really, really great job with this one, folks. Keep up the great work. Let us know if you have any questions, and we'll talk to you soon. Oh, and make yourself proud. You got it. Have a good one, y'all.